Somebody here in this room tell me what kind of body part that is that you can see here? What kind of body part is that? Yeah, let's hope so. All right, let's have a look. My name is Mario, and I'm working at the Ruhr University in Bochum. I'm contracting for Microsoft, founder of a Cure 53 penetration test firm. Maintain the HTML5 security cheat sheet. I'm more or less specialized on HTML5, SVG, JavaScript, cross-site scripting, and browser security, so I'm mainly a browser guy. And my background is mostly influenced by scripting attacks, Flash, applets, JavaScript, XSS, whatever you can think of. And for the past 6 or 7 years, I was giving talks on these topics. And I was talking about how to bypass IDS systems, how to protect JavaScript, how to use offensive JavaScript, how to do this, how to do that. But it were all kind of involving the context of scripting. And I think we all agree on the fact that there have been a lot of talks about cross-site scripting, about scripting attacks. So it's kind of a bit boring. Like there's a lot of research that has been done already. We have like traditional injections, we have like attacks from outer space using headers, DOM XSS, cross-site scripting, cross-application scripting, cross-device scripting, SQL injection attacks against client-side databases, site-wise XSS, whatever's out there, you name it. Like there's so many techniques evolving around cross-site scripting and scripting attacks that we can't even count them anymore. Same as for the defense mechanisms. We have defense mechanisms that are residing on the server, we have defense mechanisms that are residing on the client, on the network layer, and whatnot. We have CSP, the content security policy, NoScript that some people may be using in this room. We have anti-semi, which is like a very nice server-side Java-based library to protect against XSS attacks, We have the HTML purifier, browser-based XSS filters, and so many more techniques to protect against cross-site scripting attacks. So I was asking myself a very particular question. I was asking myself, given the fact that we have an injection, but we cannot execute scripts anymore because this is more or less possible on like a large number of websites, do we have to use scripting at all to be nasty, to be evil, to be an attacker, to exfiltrate, to extract data? Why use scripting at all? And this talk is going to be about scriptless attacks in your browser. This is attacks that bypass NoScript because we're not using any scripting. This is attacks that are going to bypass the content security policy because we don't have any active content being injected. We don't need any scripting for these kinds of attacks. No scripting is necessary at all, and no scripting is even allowed. We just don't need it. And consequently, we will be seeing attacks that not only work in browsers, but also in browser-like environments, such as your Instant Messenger, your Skype, and of course your Thunderbird, because also Thunderbird has a fully working HTML engine, actually the same engine as your Firefox. So our focus will be to steal your precious data without using scripting at all, just alternative techniques, just inactive markup, combined and concatenated in the right way. So this talk is a rather offensive talk. We're mainly going to see attacks today. We're going to start simple. We're going to use some cheap HTTP tricks, like play a little bit with the user's perception. We're going to be attempting to steal passwords using CSS only, cascading style sheets only. It's going to be a little bit like the sexy assassin attack back then in 2009 by Eduardo Vela, Gareth Hayes, and David Lindsay, but we're not going to brute force. We're going to do it a little bit smarter. I'm not going to make these guys bad. It's just going to be a bit faster, a bit more reliable. We're going to time, we're going to measure, we're going to log, and we're going to steal, and we're overall just going to be nasty during this talk and going to steal users' data as hard as we can. And we're going to use the browser for that. So the data we are focusing is passwords, CSRF tokens, and sensitive data in general that is being displayed on websites or website-like applications. So we're not exclusively limited to websites. We can do that stuff on TVs. So these three fellas are going to help us during our projects. This is 3 gangsters. We have here SVG Sanchez. He's going to support us with the vector-based attacks. He's the HTML Harry. He's going to support us with the HTML5-based attacks. And here we have Clive S. Dalsheet, who's going to assist us with the CSS-based attacks. So now I have a question for you. What do you see in this picture? Like, what can you see here? Don't be shy. What can you see here? Trees. Good one. What else can you see except for trees? A river. Nice one. Very nice. So there's a house, like in the back, also nice. But I see something different. Like most of you people see a river and trees and a house and some water that is going somewhere, maybe a swamp. But what I see here, because I don't have the goggles of innocence on my head, I see a side channel. I see the possibility to extract something. Like here is a side channel. The river is actually here, and here we have a small channel that is extracting water from the real river and leading it to some point. And this is like the very essence of this talk. You see something that appears to be harmless, that appears to be just some river, just some trees, but in the end you have a side channel and stuff is happening when you see it with the right goggles. So, I addressed the topic of offense already and said that this is mainly going to be an offensive talk. Defense, it's possible, but it's tough. Because in the end, we do not really use attack vectors. We just use benign features and we combine them the right way. So there is no possibility to just go ahead and write a signature and say like, hey, better be done with that. The attacker is actually using solicited content. Solicited meaning when you have like a profile page on your personal social network and you want to make it a little bit more beautiful, then the creator of the page might allow you to use some CSS, like some limited styling abilities. And this is exactly the stuff we're talking about. Like markup that you are allowed, encouraged to inject to beautify your website or to use in your HTML mail body or whatever you think of. The only essence we have here, no scripting allowed, and it's like saying thanks for the ejection. It's like this fella here who's going to the doctor's and knows he's gonna ram a syringe in his arm and some stuff being pumped in his arm, and he just assumes it's gonna be good stuff. It's just like, thanks for the injection, I know it hurts, but it's necessary, and goes home. Whatever is in the syringe, he will never know because he's probably not a chemist, but he just accepts that. And this is the scenario moving in. We accept injections, we want that stuff. All right, we're gonna see some exploits. And to give that thing a little bit of structure, I decided to put it into 3 chapters. And the first chapter is just to get you warmed up. It's like the simple tricks. You're probably going to be disappointed when you see the first ones because they're like really simple and nothing advanced here. The second one is a bit more advanced. And the third chapter is like for science. It's just like multi-step attacks that require some stuff happening, modern browsers, top modern browsers, and so on and so on. What you're going to see. Let's start with those very simple tricks. Let's assume the very following situation. We have a user, and let's call her Alice. And she has like a website she constantly visits, and let's just say this website is like Bookface. And on this Bookface website, she has like a login, and she's lazy, as we all are. She stores her password with the password manager. Well, I do this then and when, I gotta confess that. And let's just assume her username is Alice, and her password is secret. It's not the best password, I guess, but at least it's a password at all. It's not 1, 2, 3, 4, 5, 6. And today, she visits her website, like this morning actually, and she realizes that there's like a new security feature on this website. Like the website changed the login slightly, and there is now a CAPTCHA being displayed, like these numeric things, and this is how it looks like. So this is, like, of course, the simplified website where she logs in. You can see here's a CAPTCHA, and the website says, hey Alice, to make sure that you're not a bot or something nasty, please fill this CAPTCHA when you log in, and then we can log you in and everything's gonna be fine. So it seems pretty much legit, right? Screenshots are boring, so let's just give you a live demo of the whole thing. I hope my machine is not going to overheat. Sometimes it does it. And this is very nasty then. Also slow opera is slow. Oh, the precious time running away. Come on. I did not hear that. Alrighty, here we are. It's like super responsive. Heiderich. Opera. And then we go to login. So, let's get better. Let me just look up the URL. I have this sometimes. Opera capture. All right, okay. I'm getting old. Capture. Yep. All right, here we go. Finally, here's the capture, and you can see it looks like super legit. So we're just gonna fill this capture. We're just gonna say xw@?WT. So we fill this captcha, but with filling this captcha, we actually take the password and we fill in the password. Like, how is this possible? You just saw me typing xw_add, and you know that Alison's password is obviously secret. So we employed a little trick here. So we have a small injection here, which is, of course, scriptless. And let's have a look at this fella. I'm not really sure if you can see it in the last rows. Is it, like, visible? All right, otherwise just go to the website and have a look at there. So what we're having here is we have like the regular login form, and we can see like input ID X, saying like value secret, type password. This is the stuff that the browser is filling for Alice. Like we just assume that the browser is filling this in with the password manager, and then we have like input autofocus type text, so completely legit, no attack here. And then we have some kind of injection here that is looking weird, that it's not using scripting at all, but just still some styles and some stuff, and we want to know what this is. So we address the input field with the ID X, and then we use content @value, which means that we take the content of the password field with CSS and map it to the DOM, so we can see it. Like, I don't know whether this is necessary in CSS, but we have this feature. And then comes the next magic part. We give it a font family, and we say font family test. And we have already specified this font family, which is here in font face, font family test, and we're fetching an SVG font, test SVG. So now the interesting part is what is happening in this font. So we have the password field. The password manager fills the password field. The CSS takes the value that has been filled, puts it in the DOM so it's visible. And now we have a font that is mapped to it. And the font is doing nothing more but switching characters. So the S is not an S anymore, it's an X. And the E is not an E anymore, it's a W. And the C is not a C anymore, it's an @ So Alice sees her very own password, but she would never fill out, like she would never write her own password into a captcha field because she would give it away, apparently. So what she sees here is a representation of her password that just has flipped characters. So that is all. We're playing with the user's perception, we're just displaying sensitive data in the DOM with CSS, then we map a different font to it, and then we can extract the data without the user knowing that the user is just typing her very own password. So as I said, it's a simple trick, it's a cheap trick, and you're going to be disappointed. I hope you're not too disappointed. Well, we're going to move on. So, we all know validation. Like, validation is great. And when dealing with web applications and websites, we usually do validation on the server, because that's kind of where it belongs. So we have like a forum, and someone submits something, and then it goes to the server, and the server says like, nah, that's not the right thing, and goes back, and the form is red, or something like that. Validation works on the server. And with the very beginnings of HTML5, people came up with the idea that web forms in the browser are not complex enough, and we need something better. And the overhead of doing validation on the server should be eliminated, so we should rather do validation in the browser. But how can the browser know what's valid and what's not valid? So we have to give the markup, via the markup, the browser some information about what is valid and what is not valid. And that is exactly what's available in HTML5. We can use client-side validation. And this is just one example. You can see here is a name field and it's empty, but the markup says it's required, so the CSS is going to render it red. And the birthday is a little bit out of range, so the person is definitely apparently too old. The color is missing, but the flavors are checked. So some areas are green, that are valid, and some areas are red, that are invalid. And this all happens in the browser, all with HTML. So we want to use this to actually steal passwords. Can we do that? And, well, actually we can. So let's have ourselves a look. We don't need this fella anymore, please go. And at some point, I think I have some weird processes running here. Maybe if I eliminate one, it should be a little bit more faster. Oh, of course, the Chrome installer, thank you very much. And set up exe. Thank you very much. All right, now at some point, there might even be a browser. All right, here we go. No, all these tabs. All right, html5sec.org. I don't want to comment too much, and we go to /invalid. Oh, you gotta be kidding me. And we try it again. HTML5, and there we go. Yes, there we go. Okay, here we see an idealized login form, like a password field with like a super strong password. 25 characters, high entropy, like Unicode characters in there. That's like one of the best passwords of the world. If you have a look at the sources, again, we assume we're using the password manager, you can find out that it's like a very strong password. Let's have a look at this password. Password is like super strong. You can see it here, like exclamation mark, question mark, MAGM, and so on, some other characters here, and here's some messed up Unicode stuff. So it's a strong password, 25 characters. And we want to crack this password in just a few milliseconds. Can we do this? Normally we can't, unless we have like superpower, but with HTML5 we actually can. And the whole thing is working with validation. I'm just going to show you the whole process in 3 steps. This can all be done automatically, but just to have it be more demonstrative, we're just going to say start equals 1. So we know 25 characters, and we have something running. And now we have the extra information that you can see right here, like this little tiny green box, which is telling us, hey, the password in there consists of 25 characters. And like, how does it know? How can it know? Let's find out how it knows. So what we're doing here is we're injecting stuff. First, we have some CSS. Looks super harmless, right? Display none, color green. Like there is no evil CSS here, no injected fonts or stuff like that. And then we see that we not only have one password field, but all of a sudden we have like 32 password fields, all with the same name. So the browser password manager, assuming it's a bit stupid, will fill all these fields for us. And we have the password in all of these fields. And what we do is we inject a pattern attribute. And the pattern attribute is the attribute the browser can use to find out whether the content of the input field is valid or not. So we say here regular expression dot any given character quantity 0. Maybe it's empty. So is it not? This is not the case. The value is there. The value is there. So the result of the validation for this one line is invalid. So we do the next check. One character of arbitrary kind. Also invalid because it's 25 characters, 2 characters, 3 characters, invalid, 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 and so on. And this is the only line that is actually valid, that is giving us the information, hey, this form field is valid because it's got 25 characters of arbitrary kind. So every single form field that you see here, except for this one, is being made invisible. You see, input invalid is being made invisible. Whereas the other one, the only single one that is valid, is visible. So we can determine and we can find out that the visible element is actually the one element that is true. And therewith we know the number of characters for this password. But we can even go on and take this information and just say length equals 25. And then it takes some time, and my machine is going to probably go very hot. And it does this and this and this and this. And all of a sudden we extract the password. And we use 2,262 tests to brute force a 25-character password, which is even Unicode characters. And you're like, what? Like, seriously? How is that possible now? And it's the same trick. We're going to have a look at the markup of the website. And you can see now we don't have 32 input fields just determining the length of the content of the field, but we have like a bunch of fields. We just have the first field that is testing, okay, I have a pattern, and is the first character of the value the caret sign? Oh, no, invalid. Is the first character some Unicode quirkery? Because I didn't set up the char set already. Nope, move on, move on, move on. It's not that, it's not that, it's not that, it's not that, and so on. And one of these will be valid, because one of these will test for the right character. And we move on, and we move on, and then we go to the second character. Is the second one an A, B, B, C, and one of them will be valid again. And we move on, we do this for every single character in there. That's just iterating through all these characters, defining or determining whether the whole thing is valid or not. And still, the CSS hasn't changed. The invalid stuff is invisible, the valid stuff is visible. So we take the whole value from the password, we transport it to the DOM. We can see it now, it's there, it's right before our eyes. But the problem is the attack is completely pointless because it's right in front of the eyes of the victim, and the attacker cannot exfiltrate the data. So we have one step left to actually get this data and send it to an arbitrary domain. But you can see with few tests, we can take the strong password and map it to the DOM. It's now available for anything that's happening there, and something even worse. So I'm going to leave you with the fact that the attack itself is a little bit pointless. But it will not be pointless at the end of this talk, because we're going to see at the end of this talk how this very attack is going to be effective and how we can find a way to extract the data that we just can only see. So, we're moving now to the advanced class. Are there any questions so far? Was that so far clear what's happening here? Good. So, let's take a different user. Let's not Wayland Alice anymore. Let's take Bob. And Bob is like a super security aware guy. He could even be in this audience. Maybe he's here somewhere. So Bob has like online banking website, no scripts allowed, using no script, top up-to-date Firefox, super secure. Everything's working. Like his emails, PGP, S-MIME, whatever his customers want, like you name it, he has it, crypto, like he has it figured out. And Bob is even smarter, like he isolates stuff. He has like VMs running, he knows his security, he reads blogs about security. And even if an attacker would find out with which bank Bob is doing his online banking, and if the attacker would find an XSS vulnerability in the bank website, the attacker couldn't do anything with it because Bob simply just does not allow scripting to be run on his website, on this banking website. He uses no script or whatever solution. So Bob is extremely hard to pawn on the browser-side layer. So there is no Java, there is no Flash, there is no PDFs, like all this stuff is disabled for Bob. But we really want to pound Bob really hard because we're like the bad guys here, and we want his sensitive data. So what can we do? This is Bob, by the way. I think he's looking quite smart. We learned we cannot access sBob. Like there is no cross-site scripting vectors we can use against Bob. No scripting. We can thus not easily access his cookies. Like we just can't get there. But we really want to have his login data like so bad. We really want his login data. So what we can maybe do is try to jack his login form. To just do something with the login form that doesn't require scripting, but still has the capability of changing things. And you might think that now we're going to see an Opera example, but we're actually going to see a Chrome example. I changed this a little bit. And let's just assume Bob is using Chrome, because Chrome has like a strange feature. It's known as a quite secure browser, but there is like a very strange feature that I don't understand at all. And we're going to use this feature against Bob. So has anyone of you here heard about dir name? HTML5 dir name? All right, so dir name is an attribute that you can use for input elements. And the dir name is reading the values of another field, of a different field, adapting the value, and thus consequently injecting a new parameter with a given name. You might say, like, what? What is that? And there is no way to actually explain the behavior of dir name. We're just going to watch it. So let me just show you the whole thing in Firefox, because Firefox actually does it right. Here we see like a standard login, it says admin, some password, and here's some strange field, maybe a captcha, maybe not. And we submit the query. No. And we can see username admin, password is secret, and there is like a captcha string. And then we have a look at the source. And we can see form, action something, username, value admin, password value secret, and then there's this captcha thing. And here we have an injection. And the injection says dir name password. You're like, what is this thing? And now let's have a look again. Let's have a look with a different browser. Let's take our good friend, the Chrome Canary, because it's still working in the latest version, at least I hope. All right. Let's just have the two things together. Like, you know, I submitted here admin secret and some captcha. Now I'm going to submit the very same form in a different browser. And all of a sudden I can see admin, liter, and the captcha field. So the password field has changed. Like we have no differences here. Like this is the very same markup. Let's have a look. It's the absolute same thing. We can see username admin, password secret, captcha, dir name password. Nowhere in this form we can see the value LTR, but still we get LTR. So how is this possible? The problem is that dir name, as I said, is kind of Unicode text flow direction indicator. So if you inject a dir name into a form, then this dir name is going to listen for a specific form value and going to find out if the text flow direction is going left to right, LTR, or right to left, RTL. And then the dir name needs an attribute which is giving it a name, and this attribute will then be a new HTTP parameter. So the server can know in which direction the text flows or not. And the smart thing here is, or the less smart thing regarding Chrome and regarding the creators of the specification, is that existing values will be overwritten by dir name. So if you have a password field already, then dir name password will overwrite this value and just fill in LTR if it's left to right, or RTL if it's right to left. And well, this is quite nuts, because if you bring this into the context of a registration form, you can just not guess users' passwords, you can just overwrite users' passwords with just one injection. You just say dir name password, and then the user's password is being overwritten with most likely LTR, and in some cases RTL. So you know the password because you overwrite it in the background. But unfortunately, Bob is not using Chrome. And Bob is using Firefox with NoScript, as I do, and Bob is using Thunderbird with Enigmail, as I do. Like, there's some parallels except for the 10. So we might think that Bob's pretty much unpoundable. Like, we cannot do anything to pound Bob, but we want to do it so hard. We really want to pound Bob, right? And let's say admin time. And let's develop a targeted exploit against Bob. We really want to have his data, right? And this exploit needs to be working on Firefox, and ideally it needs to be working on Thunderbird, and it should also be bypassing latest versions of NoScript, because that sucker uses NoScript. But how can we do that? And can we do it at all? Maybe we can. Let's have a look. So we have, again, like a very harmless login page. We have so many harmless login pages, right? Let's have a look at this harmless login page. And you can even guess by the name of it, which you can find here. It's just like username here, it's just like admin, I see, correct, and I log in somewhere, and everything's fine. Looks completely legit, like nothing's happening here, right? So now let's have a look at what is happening on the network layer. Unfortunately, I think this test Firefox doesn't have Firebug installed. That's unfortunate, but I have a backup Firefox here. Let's just take this one. So let's have a look at the network traffic. Most of you might know Firebug, which is a nice debugging extension, and it gives you the possibility to watch what's going on the network. And again, we go here, it's just like admin, like wait a second, what is going on down here? There's requests going out, http://evil.com admin. So this thing is leaking my username? Oh, that's not cool. And then we go like wait a second, this is leaking as well, SECRET. But there's nothing here. I even have scripts disabled. So the point is, we have an injection that is working with SVG, with scalable vector graphics, that doesn't need scripts, but still has the capability of leaking your keystrokes and recognizing your keystrokes. Like, how does this work? Let me just zoom it a little bit because it's pretty epic. You have, again, like the regular form, nothing bad here, no trickery, just harmless form elements. And then you have like an injection block. You have an invisible SVG image, and this invisible SVG image essentially has one element, and this one element is an image. And you can see here we apply this image with the xlink href, so the image source none. And then we use something special inside the image, and we use set elements. And SVG is the only language that has a way to declaratively change surrounding elements. So if I take a set element and put it into a different element and instruct the set element to do something with the surrounding element, then it will do this, whether there's scripting enabled or not. And what we're doing is here we're saying like, hey, set, you need to influence image because it's your parent element. And I can even take 10,000 set elements that are all influencing the image element. We say like attribute name, xlink href. So dear set element, please influence the attribute xlink href of the surrounding element, which would be this. And set it to evil.com A, B, C, D, E if something happens. And this is, the magic is happening in the begin attribute because SVG has a keystroke API, and this keystroke API is working independently from scripting. And we can just say access key A. So whenever the key A is being pressed on the whole page, SVG is going to change the URL of the image that is surrounded by that is surrounding the set element, and thereby sending out an HTTP request. And same thing here. If we press the key B, then the URL is going to be changed to B, and so on. Press the key C, and so on. So this is pretty nasty, and this is nasty because it works without scripting. And I filed a bug, and the bug was fixed in a way, and the people at Firefox's, at Mozilla's bug tracker were like, yes, like medium criticality. I was like, guys, that's not medium criticality, because if it works in Firefox with no script, that has, okay, not so many users, 2 million, but then it might work in different software as well, where you don't have any scripting. And when you Google for Thunderbird and want to steal a nice picture of a Thunderbird, then this is what you find. This is the son of Thunderbird, apparently. So yes, it works in Thunderbird. You can send a user a mail containing SVG. Per default, SVG mails are enabled in Thunderbird. Look it up. And the mail body can contain the SVG, which can contain the sniffer code, which will then log the keystrokes that you are doing in your mail. And that is not so cool. You want to see the demo? Anyone wants to see the demo? No, right? Oh, okay. So here's my server log. I hope I'm still connected. And like this is my evil server. And this is Thunderbird. And like I said, default settings, try it out, it's not hard. And I just gotta get some mails here, suspicious sign-in prevented, alrighty. Blah, 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 test mail, okay, let's check this test mail. Oh, cool, a mail. Then I would reply it and I would just say like, A, B, C, D, E. A, B, C, D. Come on, 0. Right. All right, I'm gonna go back to the mail and type around in the mail A, B, C, D, E. And you can see my server on evil.com, I redirected it a bit, is receiving requests. And the request is saying the key A was pressed right within the mail, and the key B was pressed right within the mail. So tell this to your PGP and tell this to your S-line, because it doesn't matter, because the attack happens after the mail has been decrypted already. So it's happening inside the mail body. Like if you reply to this thing and type something, well, then someone is going to read this. And if you, for example, construct like one of these key phrase dialogues with a nicely looking image and have the user think that he needs to type in his key phrase for the encryption or something like that, you can sniff this as well. Like this is the perfect entry vector for like a social engineering attack on a technical level. And actually, I gotta leave it to the Mozilla guys, this was fixed. So this is not working anymore, but it bypassed no script. It worked in Thunderbird in the default version, default installation, no extra settings, and it worked in latest Firefox. So we have seen how we can abuse scriptless markups such as SVGs to access keystrokes and to do nasty things and to just channel them, exfiltrate them to some external server. And you might want to think that SVG should at least specify and say like, okay, if you do that, then just have it for like the SVG image itself. But the problem is, as you could see, it's working for the whole document. So the keystroke is actually working for the whole document. It's not working across iframes, but it's working for the whole document. So that was nasty, and then the criticality was elevated and was fixed, and well, thanks SVG Sanchez. All right, so we've made our way to the advanced class, and I think now it's time for the science class. Let's take a deep breath. So, for science, who here knows CSRF, like the attack technique CSRF? Good, those are some people. Who doesn't know CSRF? All right, so consider you are using a forum, like a PHP forum somewhere out there, and you want to troll the admin. Then you make a post, and this post goes like, hey admin, you're stupid. And then you embed an image, and like with BB code, like a rectangular img, rectangular closing, and then the image URL. But the image is posting to logout.php, because the browser doesn't care whether it's an actual image or not. It's just request is request. HTTP is stateless and doesn't know anything. So the admin sees that, goes to this page where it says admin is stupid. He wants to delete it, but he's being logged out by the image in the background. He just doesn't know it. So he wants to delete it, and the forum is going to say, oh no, dude, you're logged out. You can't delete the post. And he's like, I'm going to log back in and go to this thread again and delete it again. And same thing. Like the image request is firing a request to the logout URL. Thus, he cannot delete the image because his state is being changed. And this is like a very, very common attack in web applications. You see this everywhere. The protection against CSRF is to make links and requests unguessable. So attach something to the link that you cannot guess it, like a token, like a nonce or something long that is cryptographically safe or whatnot. And make sure that the attacker cannot guess it. So in another tab, for instance, or in another browser or with the same cookies, no one can predict the links that are sensitive. No one can delete your account or worse. And we want to have these tokens. And because they're nice and we can do nasty stuff with them. We can lock people out or even worse, or reset up coffee machines with a web interface. We have easy ways to do that with cross-site scripting. So CSRF attacks and cross-site scripting are pretty good friends, because with XSS you can actually read the token from the DOM and then just recycle and reuse it, and then you are. But remember, we're not using any scripts. We want to do it without any scripting, because we also want to read CSRF tokens without having any scripting enabled at all. And can we do that? So, as I mentioned in the very beginning, Sir Darkhat, Gareth Hayes, and Thornmaker already did it in 2009 with the sexy assessing. Check this thing out. This is really, really awesome work on CSS research. And they used attribute selectors. So in CSS, you can, for instance, say value first letter is A, then it gets a distinct background. So if the value starts with an A, then it gets a different background as an element that starts with, that has a value that starts with B. And thus you can tunnel out GET requests, but to guess the whole thing, especially like a 32-character token, you need a lot of these. And the problem is you have to brute force, because there is a first letter selector like this, caret equals A, but there is no second or nth letter selector. There is a last letter, first letter, and somewhere in the middle. So you have to brute force. You have to lose a lot of requests to find out a 32-character token. Like, it's actually several million requests. And if you remember the password thing that we were doing with the second demo, we just used 2000 tests because we had the power of regex, but we're going to escalate it even further. So what they had to do was just like go to the whole thing, so like test AA, test AAA, test AAA, and so on to find out what the actual value is. So really, really tedious. We don't have that time. We're attackers. We're nasty. We need to get stuff done quickly. So we cannot use this kind of brute forcing approach. Also, the user is going to notice. We need something quicker. And I came up with an attack that is working on WebKit. And I decided to cook some crazy CSS and to find out whether it works, and it actually worked. So let's have a look. We need some ingredients here to extract sensitive data such as C-serif tokens only using CSS. The first ingredient is height. Harmless, right? It's just the height. Then we have width, also harmless. Why is the cursor here? Then we have, again, our good old friend, content utter href. So we extract the content, the value of a link, and put it into the DOM. Then we have overflow minus x equals none, so it doesn't overflow into the horizontal direction when it's bigger than its surrounding box. Important. Then we have font family again, so we're gonna do nasty stuff with fonts again, and another secret ingredient. So this is how it looks like. And this is probably not telling you a lot, so again, we just better have a look at the live demo. And hope that it still works with the latest Chrome Canary, because the bug was already filed. But I got a backup Chrome just in case. All right, that is the magic, and it still works. Awesome, latest Chrome. So what can you see here? You can see an animation. Let's repeat it. And no, I don't want to have it translated. And the animation decreases the size of the box, and then some things appear, like these little rectangles appear. Let's have a look at it again. And there are the rectangles. 5 of them, not 6. Let's try it again. And there is one missing. So what is happening here? Let's have a look at the sources first. No, you go away. So we have a lot of CSS. We have a lot of fonts. We inject like tons of fonts. We inject a font that says test S, test E, test C, test R, test Z for the counter test, and test T. Then we have a lot of CSS here, and even more CSS, and more CSS, and then we have some weird stuff here, and then we have even more CSS, and then we have some harmless links, the ones who carry our secret token. So what we are doing here is we do not inject one single font. We inject one font per character that we want to exfiltrate. So imagine you have a font that only serves one character. Let's say the A, and the A has distinct dimensions. So the A in this font will be 100 pixels in size. The B, 0 pixel, C, 0 pixel, D, 0 pixel. So if there is an element on that page that contains the letter A, then it will have dimensions, because the A is there. If the element does not contain an A in its text, then it will have no dimensions, because the other characters have dimension 0. So therewith we can find out whether an element has dimension, and if the element has dimension, the character we're looking for is there. We're doing the same thing for B, so we have an extra font that only has the B, distinct with 101 pixel. Then we have the font for the C, no letter in there with dimensions, only the C, distinct with 102 pixel. So we can even find out that if the box has a special width, that this character must be part of it. So we are even one step closer. And if you follow that whole train of thought, you will find out that we can easily enumerate the characters that appear inside an element by the width of the element. Because we have the distinct width of the characters, we just have to concatenate them and find out the final width, and then we can find out what the characters are. And what we also have to do is to exfiltrate this data. We have to get it out. And this is the part where the overflow is coming in. So imagine you have a box, and the box has content, like dimensions, one of these characters, like let's say 105 pixels, and you decrease the box size. Then something in that box is going to break to the next line. And if something in that box breaks to the next line, a scroll bar appears, because it indicates, oh, hey, the box just grew in size, so you want to scroll down to see all the content. That's what browsers do. So we know when a certain width of the box has been reached, that there's going to be a break, and in this very moment the scroll bar is going to appear. So maybe we can use the scroll bar as a side channel, because if we find out in which moment the scroll bar appears, then we know the size of the box, and therewith we know the character that is inside that box. You following? Is it possible to follow that? Let's have a look at the demo. So let me just show the network requests that are happening here. We can reload the page. You can see all the fonts are coming in. And then here's a request, ERSCT. But there is no Z. One of these things contains a Z. So that's like the counter test. That we can see we have the possibility to find out just by using the box size and the animation and the information of the scroll bar appearing what kind of character is being used, and then we send out specific requests. So we can find out that the password or the token here contains the characters ERSCT, which are in assembly going to form the word secret. So how is this working? Like, we have to find out when the scroll bar appears. And WebKit has like a very specific feature that is styled scroll bars. And we can give a scroll bar styles, thus we can give a scroll bar backgrounds. With a background, we can find out that something happens because it sends a request. And I was trying to, okay, let's just style the scroll bar and hope that the scroll bar is going to appear in the very moment where it's visible. But unfortunately, that did not work because the scroll bar appeared on load, like the request was being done on load. So I had to continue my research, and in the end I found out that there was one single selector, which is this fella here, which is minus WebKit, minus scrollbar, minus track, minus piece, colon, vertical, colon, increment, that is sending the background request at the very millisecond it's appearing. So we have that side channel now. We can extract the information. We know what the dimension of the box is because we know when the scrollbar appears, thus we know what the character is inside the box, and we can extract the data, as you could see in the live demo. So this is nasty. And I reported this to the WebKit guys and to the Chrome guys, and they said like, nice bug, but yeah, we're not going to fix it. I was like, what? You can exfiltrate data with CSS by using smart scroll bars? Like, this is pretty fucked up. And I was like, yeah, no, we're not going to fix it. And I was like, okay, there must be reasons for that. They're not lazy, they're pretty good researchers, so keep digging. And I found out that you can actually not only do this in WebKit, but you can do this in every single browser out there. This is not a limitation, and you do not need the intelligent scroll bars. And this is going to be the last attack I'm going to show you. And it involves an extra feature. So HTML5 brings us new blessings with the possibility of using external forms. And one of the recommended form formats is WOFF, Web Open Font Format. And these WOFF fonts are like super complex. If you're a typographer, you will love WOFF because it supports everything you need in typography, like all these interesting features. And one specific feature that is very interesting for us here are discretionary ligatures. And discretionary ligatures give you, as a developer of a font file or of a website, the possibility to replace a string consisting of like n characters with one single character, with one single, let's just say, glyph. So if you have the string cat on your website, you can have it be replaced by that font with a kitten icon. If you see the string deer on your website, you can have it be replaced with a little reindeer. And this is actually a feature, and it looks like this. So here you can see cat, like here's a regular string, and as soon as we enable the discretionary ligatures / contextual alternatives, we can see it being replaced by a cat icon. This is not an image, this is a character. But that gives us the possibility to group characters and to give even groups of characters distinct width. So we can do nasty stuff with that, right? There is a tool that gives us the possibility to do all this for free. We don't need any expensive Adobe software. It's called FontForge. It's open source and it's pretty awesome. And here you can see the dialog where I'm modifying the character R and having it represent the string supersecret. So if somewhere on the website the string supersecret appears, then it will be represented by the letter R. And it gets a completely different width because R versus supersecret, you know where I'm heading. And again, we have the possibility to determine the width. So what we can do right now is we can build ourselves attack fonts. Like who here now knows John the Ripper? John the Ripper, like this password cracking tool? Yes. We can build fonts that do that. We can have a font that is containing dictionary lists of passwords or credit card number groups and assigns them to special characters with a distinct width. And then we can use the WebKit trick to find out if this string of characters is appearing on a website, channel out the data by maybe the intelligent scroll bar or any other possibilities that we're going to see soon, and then we have the data being extracted. And for credit card numbers, for example, you have number groups, 4 numbers, 6 digits. It's easy to make a font to do so. And fonts are being optimized for containing a lot of character data, a lot of vector data. So in our tests, it shows that it's very, very easy and feasible to create a font that contains a dictionary of 100,000 strings. And this font is still small. It's not like it's 10 megabytes or so, because the representation is just one vector, 100 pixel, next string, 101 pixel, next string, 102 pixel, and so on. This is all you need. So if the character or the group of characters is actually visible, we have a hit. We can determine the dimension, we can exfiltrate the data, we can use the intelligent scroll bars. You can enable the whole feature with the discretionary ligatures by using mods-font feature settings in Firefox and an Internet Explorer with MS-font feature settings C-alt, like contextual alternatives. So I wanted to find out why the Google guys were like skeptic and said like, now we're not going to fix it. And I found that there is indeed, like I said, a way that you can do this in every single browser. You don't need the intelligent scroll bars to actually extract the data. Who here knows CSS media queries? Like, this is a pretty wacky invention. Imagine you go to a website with your smartphone, and the website says like, hey, you have a smartphone because I can detect your screen width, and I can do this by CSS, and then I just give you the style sheets that are usable for the smartphone. And then the next time you visit the same website with a desktop computer with like a larger resolution, and the website is going to say, hey, my CSS just found out that you have like this dimension of your screen, so I'm just going to give you this CSS, and this is good for you. So we can measure the width of the view part of the screen or of the browser window using CSS and react accordingly. So remember the animation with the shrinking boxes? We can do this with media queries. We can just have a window that's shrinking itself, and the CSS inside will say like, hey, now you're 300 pixel width, now you're 200 pixel in width, now you're 100 pixel in width, and every time give you different style sheets. So we can actually use this to find out whether there's a scroll bar or not. And you can see this. I got a last demo, and then I'm done with the talk already. I'm just getting the finish sign. We can, for example, just use it with Internet Explorer and go to html5sec.org and scroll bar /test. Yeah. I'm going to be a bit lazy here. I'm just going to resize the window. In just a second. I'm sorry. So you can see the window. And we have an iframe in here, and this iframe doesn't display scroll bars. We still want to find open scroll bars up here, right? So we just resize it a little bit and move it around a little bit, and once we decrease the height, the scroll bar has to appear because stuff is breaking. The scroll bar appears, the CSS media query activates, turns the whole thing red, sends us a background request, tells us we have scroll bars. Thus, we can use the whole thing to determine the width of a box. Thus, we can use the whole thing to determine what kind of characters are inside that box. Thus, we can exfiltrate the data. And there is no script involved at all. So what we have seen here was like the classic exploit. We found a feature, we had like an urge, we wanted to pound Bob. We had a look at the specifications, we took all this stuff, we swapped it together, and in the end we developed an exploit that is capable of extracting arbitrary data from a website, attribute data, content data, whatever you want. So we're almost done. We learned that today everything is a side channel. Once there is a feature that can send out background images or alike, we have a side channel because it can tell us stuff. Combining that with other features might leak information that we don't want to see leaked. And the conclusion that we can draw here is that scriptless attacks compared to cross-site scripting are not that bad. Like, we cannot directly read cookies and stuff, but we can read website content, and it's feasible, like you saw the demo. And this is affecting a lot of things. This is affecting NoScript users, this is affecting CSP users, this is affecting users of sandboxed iframes, that is another invention in HTML5. That is affecting users of Thunderbird, of instant messaging, of Skype, whatever does not execute scripts. This is even affecting users of Windows 8 if you have like Windows 8 applications running. So it's a tough thing. And we can utilize timings, we can utilize side channels, we can utilize dimensions, scroll by appearance. And the only thing that you can actually do right now in terms of defense is install NoScript, like use Firefox and NoScript, because ironically, NoScript fixes against these attacks, although they're not scripting based. I was in contact with Giorgio, and he fixed all the stuff, so good thing. Like I already said, defense is tough. The only thing that you can effectively do is reduce the side channels. You cannot fight the vectors because the vectors are too complex and just too versatile. The only thing you can do is fix the side channels. Make sure your website does not leak data to other domains. And for that, you can use CSP. And, well, we're coming to an end. As you can see, there's a lot more in this. This is just like basically, the sky is the limit in terms of creativity. I'm pretty sure that if you have a short look into this, you will find different attacks that accomplish the same or even more. So everybody feel invited to just have a look at this topic and do some research, because it's actually fun if you can see how to combine benign features to something nasty and then actually get through with it. And I think that even if we manage to defeat cross-site scripting or scripting-like attacks, there are still exciting times to come along with CSS, SVG, and just harmless markup. So that was it. I hope you have any questions. Maybe there's a discussion. Maybe you want to look me up afterwards and just give me a beer or something. Just to stay in context, before this presentation, I put online a small cross-site scripting challenge. So if you want to solve it, be my guest. If you do solve it before the panel, then I will do the panel with Mickey Mouse ears. And if you do solve it in a very excellent way, then I will do the panel with Mickey Mouse ears and a face painting. So have fun with the challenge. Thank you very much.